Hello everyone and welcome back to 3DAF. My name is Zander and today we're going to talk about how temperature affects the quality of your 3D prints. But before we get started, go on down to the comments below, let me know what your favorite material is and what temperature you printed at.
A lot of people ask, what is the best temperature to print at for whatever material? And they will receive a range or a variety of answers depending on the group they ask. The truth is that all materials have an effective range for printing, and which temperature you choose will heavily affect the quality and cohesion of the print. So first, let's review the theory of FDM adhesion. Filament comes out of the nozzle more or less round when purging in the air. When filament is extruded in a print, it is compressed against the prior layers, creating more of an oval shape. As the filament is extruded hot, it reheats the top surface of the layer below, creating an adhesion zone. The size of the adhesion zone depends on a few factors. Nozzle diameter. The adhesion zone width is typically close to the nozzle diameter, so the larger the nozzle diameter, the larger the width of the adhesion zone, which is represented by these two red lines here. Temperature. The hotter the print temperature, the deeper the penetration into the adhesion zone, the better adhesion between the two layers. The adhesion zone here is represented in red as the covalent area between the original nozzle diameter. Layer height. The lower the distance between layers, the greater the compression and spread, the larger the width of the adhesion zone. In this particular illustration, the layer height is shown in these two blue lines here, and as they compress, the red adhesion zone would push further and further out. Speed. The faster the material is laid down, the less the material cools between leaving the extruder and entering the adhesion zone. So print at the max temperature, right? Well, that depends. Printing at the highest temperature will increase the strength, but as the heat passes through the layer below, it can soften that layer, allowing it to sink and distort. So in fact, you are increasing the strength while sacrificing the print quality and dimensional accuracy. If strength is all you need, then this might work for you. Keep in mind that this will also reduce your ability to bridge larger areas, requiring more infill and exterior support than a lower temperature print. In most materials, the end result of the print will also be shinier if you printed it at a higher temperature range. When you print at the lowest temperature range for the filament, you are more likely to have a better surface finish and tolerance, which will usually be more visually pleasing. If looks are what you're in for, then this is the way to go. Low temperature printing will allow you to maximize your bridging, even in poor bridging materials such as polycarbonate and ABS. In most circumstances, you will want to print in the middle range if you want the best blend of strength and quality. The best way to determine the optimal print temperature is to use a temperature tower, which we will cover in more detail in our next video on FDM.
Are you still here? Alright, fine, you want to hear the fun joke. We have this entire tower of Timmy's cups represents what Zander drinks in 1 week to make all these wonderful videos for you. It's all for you guys.